Bismillah, alhamdulillah, salatu wassalamu ala rasulillah. Our class, inshallah, will be about the rest of P7. If you remember, we have achieved the first three objectives in the previous class. Always, ya shabab, do you want to check if you understood what was in the previous lecture, or how to check that you achieve the objectives of every section? Ask yourself, can I find the domain? Ask yourself, can I find the domain of an algebraic expression? Can I simplify rational expressions? How to simplify? Let me see. Are you okay with this? How to simplify rational expressions? Yes.
Expand, then you cancel the same.
No. Factor, not expand. Factor, and then cancel the common factors between the numerator and denominator. Similarly, check, add, subtract, multiply, and divide rational expressions. Today, our objectives will be what? How to learn how to simplify compound fractions, what we mean by compound fractions, and how to rationalize denominator or numerator. And we did that before, but we will generalize it. And most importantly, how to avoid common errors. So listen, we will start with compound fractions. What we mean by compound fractions or complex fractions. A compound fraction or a complex fraction is a fraction of fractions. When you have a fraction that its numerator and its denominator, both of them are fractions. Let me give you an example from B2. Do you remember that I told you, Shabab, that if you are okay with B2, you will be okay with P7? Let's say a half minus 4 over a half plus 2 over 3. This is a compound fraction. It is a fraction of fractions. You have here a fraction. By the way, how to find the result of this, ya Shabab? How to simplify this? How to simplify this expression? The idea. Yes.
Subtract the numerator and add the denominator by itself.
So what you mean, this is the main fraction bar.
Yes.
What you will do, you will simplify this.
Yes.
So you will write it here. We have here two fractions. We will write it as a single, as one fraction. So what we will get in this case, what is the LCD? 2. You will have 1 minus 8. Is that right?
Yes.
You do the same here. The LCD is 6. And you will have 3 plus 4. Is that right?
Yes.
What we did, ya Shabab, we have here two fractions, here two fractions. Now we wrote them as a single fraction. Keep in mind what is the main fraction bar. What is the main numerator? The main denominator. Now this is equals to what? A negative 7 over 2 all over 7 over 6. Is that right? Now you need to remember, when you have A over B all over C over D. What is that? This is A over B multiplied by D over C. Keep this always in mind. So this is negative 7 over 2 multiplied by what? 6 over 7, which is what? 7 here is a factor, 7 here is a factor. You can cancel them. So you will get what? Negative 6 over 2, which is negative 3. What we did here, we will apply it here in a similar manner for the algebraic expression. Let me show you this. Here we are. This is a compound fraction or a complex fraction. You have here, this is the main. Ask yourself, what is the main fraction bar? Now, write this as a single fraction. Write this as a single fraction. Then do multiply, invert and multiply. The same idea. The illustration is here, ya Shabab. If you want to understand, you need to read. So we combine the terms in the numerator into a single fraction, into one fraction. And we do the same for the denominator. And here we are. What you can do for rational numbers, you can do it for rational expressions. The LCD here is y. Now you need to multiply x by 1 and 1 by y. So it will be x plus y over y. Here it will be x minus y over x. Now it will be what? This multiplied by the reciprocal of this. Here it is. Now, can we cancel y with y?
No.
طيب, x with x?
No.
No, they are not, of course. This y is a factor, but this y is not a factor. It is a term. So you cannot do that. So according to that, what we will do? How to multiply? How to multiply rational expressions? Numerator by numerator, denominator by denominator. You can expand if you want. You can write it as x squared plus xy over yx minus y squared. You can see here that this is solution number one. Is there another way to solve this? Yes. The another way is about what? What is the LCD here? Y. And here? So what is the LCD? The LCD of all the fractions? XY. Multiply the numerator by XY and the denominator by XY. You are multiplying by one here to keep the value the same. So now when you multiply XY by the numerator, you will have what? X plus XY. X squared plus XY. And when you cancel it here, x with x will cancel, you have y squared minus, here you have xy, which is the same answer that we had before. It is the same if you take x here as a common factor and in the denominator y as a common factor. This expression, ya shabab, is from Math 101. You will see this in Math 101 when you find the derivative of the function 1 over x. You will remember such examples like that. Now, what you will do, you will just ask yourself, what is the main fraction bar? Here it is. So we have here two fractions. We need to write them as a single fraction. So this is h as it is. Now you will ask yourself here, what is the LCD? How to subtract? Just write the LCD. The LCD is a multiplied by a plus h. Now here it will be a minus. Don't forget to write minus and then brackets. If you didn't write the brackets, it will be wrong. Now distribute. Now what we have? We have a single fraction over a single fraction. Now the mistakes coming here, ya shabab. When you have a over b over c, how to write it? You need to ask yourself, what is the numerator and what is the denominator? What is the main? What is the dividend? What is the divisor? Now, look, it is different. A over b, it is over c. This is something. And a all over b over c, this is something else. Okay? Here it is a over b multiplied by 1 over c. Here it is a multiplied by c over b. You realize the difference between them? The difference that the main fraction bar here is, what is it? The main fraction bar here, it is it. What is the dividend? What is the divisor? What is the main numerator? This is the main numerator. This is the denominator. And here, this is the numerator. This is the denominator. Okay? So here, what we will do here? This is, of course, ya shabab, the main fraction bar. So this is our numerator. This is our denominator. So this will be what? H over 1. So what we will do, we will write this as it is, and we multiply it by the reciprocal of h, which is 1 over h. Now simplify here a minus, distribute the negative, and make sure when you distribute it, you do it in the right way. The distributive property, the most property that is repeated in this course. Now a minus a is 0, and we have negative h over a times a plus h times 1 over h. This h is a factor. This h is a factor. We can cancel common factors. So what we will have in the numerator here, we will have here negative 1 multiplied by 1, which is negative 1 over a times a plus h. What you will do in Math 101, you will just find the limit when h goes to 0 for this. A times a plus h, which will be negative 1 over a squared. H will be 0. A times a is a squared. That's it. So most of the work is from here, from 0, 0, 1. You can do, of course, ya shabab, by multiplying the LCD of all the fractions, the same as we did in the previous example. Now, I expect now you can solve this recitation exercise. You can solve this one. Simplify the following expression. This is question number 2 in the recitation. If you got the idea, it will be so easy. Let me pause the recording and take the attendance. Continue solving. And if you finish, you can check your solution. This is the final answer. Check your solution. Now let's come, ya shabab, to the common errors that may happen with such a problem like this. I have noticed that many students did this mistake. Let me write what they say, what they did, and please tell me why it is not true. Look, we know that x to the power minus 1, it is what? 1 over x. This is so common. So in general, a to the power negative 1, it is 1 over a, if a is not 0. So what I will do, look what I will do, and many of you, they did this. This x minus to the power negative 1 will go down. This will go up. Plus, this will go down, and this will go up. Many of you, they did this. And look how lucky they are. 2x plus 2 over 2, which is x plus 1. So it looks like it is correct. It is just coincidence here that the result is the same as the result of. In fact, there are here many mistakes, not only one mistake. This is a mistake, of course. This step is not correct. Even here, the negative, you need to distribute it. So there are many mistakes here. From where this mistake is coming, ya shabab? It's coming from here. You know this is correct, but you apply it in a wrong way. Let me ask you this. Let me ask you this. You know that x inverse is 1 over x. Y to the power negative 1, it is 1 over y. If you add them, it will be like this. Is this correct?
Yes.
It is correct. Now, what about if it is x plus y, but it is in the denominator? Is it? I'm asking, is it x will go up and y will go up as you say? Is it correct? This is not correct at all, ya shabab. How to show that it is not correct?
Let's simplify.
Bring this one. What is this? This is 1 over, what is x to the power negative 1? It is 1 over plus 1 over, what is this? This is the LCD here is xy, and here it will be y plus x. This is the one, and it will be what? xy over y plus x. Look, what is it equals to? Not this one. Now this is correct. This is what you have. The mistake is coming from applying what is for multiplication. You do it for addition. Look, let me ask you this. X inverse, x to the power minus 1 and x to the power negative 1 times y to the power negative 1, all in the denominator. This is equals x to the power xy. This is correct. Why? Because this is 1 over x, and this is 1 over y, which is equals to 1 over xy. And you know that this will be multiplied by 1, it will be xy. So what is applicable for multiplication is not applicable for addition. Be careful, ya shabab. Similarly, x plus y all inverse. It is not x inverse plus y inverse. Let's say 1. I mean here by inverse by the way negative 1. I used to use that in math 002. So now how to solve this, ya shabab? This solution is wrong. Be careful about that. So what you should do in this case is do it in the right way, in the formal way. How? What is this equals to? This is 1 over x plus 1 over x plus 2, all 1 over x minus 1 over x plus 2. This is how it should be done. Next. Now you have here two fractions. You need to write them as a single fraction. So this is the main fraction bar. This is the denominator. This is the denominator. Now we will write it as, let me go a little bit down. This is the LCD here is what? X multiplied by x plus 2. And here we will have x plus 2 plus x. Is that right? Just I multiply 1 by this and this by this. Similarly, in the denominator, we will have x times x plus 2. And here we will have x plus 2 minus 1 times x, which is x. Now, how to divide now? It is not a compound fraction anymore. Halas, you have single fraction. This is single fraction over single fraction. So how to divide single fraction over single fraction?
We get the reciprocal of the.
Invert and multiply. Invert and multiply. So we will do it like this. You can do 2 steps in one, ya shabab. You can add here x plus 2 plus x. What is this? This is 2 plus 2x over x times x plus 2 multiplied by, now you will invert this. So it will be x times x plus 2 over what? Over x plus 2 minus x. X minus x is 0, it is over 2. And now you can cancel. Because here, x is a factor, it is a factor here. X plus 2 is a factor here, it is a factor. By the way, shabab, you should know from the beginning that you multiply by the reciprocal. You can cancel here in this step. But be careful. Are you canceling the denominator of the numerator with the denominator of the denominator? You have to do it in the formal way if you are not sure. Now we are done. We have now 2 plus 2x over 2 or 2x plus 2. It is the same. Now take 2 as a common factor, 1 plus x over 2, or distribute 2 over 2 plus 2x over 2, which is 1 plus x or x plus 1. The addition is commutative. Clear? Okay. So mistakes and errors are corrected. I hope so. Let's see if it is corrected or not. Tell me, what is this equals to if you simplify it? Check your answer. Is it like this? This is the most simpler form that you can have for your expression. Okay. Where is the mistake? If you did a mistake, where it is? So what we have here, shabab, we have 1 plus, now we have here, this is a compound fraction. We have here 1 over, we need to write these 2 fractions as a single fraction. So how to do that? We will write them over the same denominator, the common denominator. So here the denominator is 1, so we need to multiply 1 by 1 plus x, and this will be plus 1. This is equals to 1 plus 1 over, this is x plus 2 or 2 plus x, as you want. That's right? Now, when you have 1 over a over b, you should ask yourself, which one is the main fraction bar? It is this one or this one? So here it is this one. So it will be what? 1 multiplied by b over a, which is b over a. So this, in fact, will be 1 plus, again, it will be the 1 multiplied by the reciprocal of this, which will be 1 multiplied by 1 plus x over 2 plus x, which is, in fact, no need to write this one because 1 multiplied by any number is the same. So I will write this as 1 plus x over 2 plus x. Now, again, we have 2 fractions. Don't stop here, shabab. You can simplify more. The LCD is 2 plus x. Here, the denominator is 1. So you multiply 1 by this, it will be 2 plus x plus 1 plus x. What is that? 3 plus 2x over 2 plus 2x. It is better, by the way, to write it like 2x plus 3 over x plus 2. Why? Because this is the standard form. We usually start from the highest power to the smaller power. But it's okay. The addition is commutative, no problem. How to simplify expressions when you have rational exponents? This is important. We did that also in P6, how to factor.
Yes.
You will use that idea here. You can use it. Why not? So here, for an instance, we have here 2 terms in this numerator. So what we can look, we have here expression, the same expression. Here it is to the power half, it is to the power negative. So we have a common factor here. What is the common factor?
X squared plus
We have a power half, a power negative half. We will take the smallest exponent. So we will take the LCD to be 1 plus x squared all to the power negative. This is the common factor, the GCF, the greatest common factor. Now we will factor it out. We will open brackets. Now, when you divide this by the common factor, what you will get? 1 plus x squared to the power half. You are dividing this by 1 plus x squared to the power minus a half, which will be 1 plus x squared to the power 1 over 2 minus, it will be plus, which is what? So here it is, 1 plus x squared all to the power 1. We don't write 1 in the power. Similarly, you will divide, this is minus, here it is. This is the minus that we have here. Now you will divide now this term over the common factor. It will be this over itself. 1 multiplied by x squared, it is x squared. Okay, here we are. Now here you have 1 plus x squared minus x squared. What is that? X squared minus x squared, 0. 0 plus 1, 1. 1 multiplied by this expression, it will be that expression. Are we done?
No,
We
we can't simplify more.
can simplify more. How?
By dividing.
When you have a to the power m over a, can you simplify? Yes. It is a to the power m minus 1. So here it is just 1 plus x squared all to the power what? Negative half minus the power here is 1. Minus 1. What is that?
Minus 3 over 2.
This is the same expression all to the power negative 3 over 2, which can be written as 1 over.
Can we write in the algebraic form?
Why not? Yes, of course, you can. But usually it is better to keep the output as the same as the input. He gave you rational fraction. It's okay, no problem. Now, the another way, Shabab, is similarly as we did before. You can solve it, by the way, in another way. What is it? Let me show you how to do that from here. You can write this as 1 plus x squared all to the power half plus x squared over 1 plus x squared all to the power half, all over 1 plus x squared. Is that right? What I did, I just write this instead of in the negative power, I convert it to a positive power and put it in the numerator. Where is minus?
With the two terms.
This one you mean?
Yes.
It is subtraction, yes. Right. Now what you can do, what is the LCD? Is this is the LCD. So multiply numerator and denominator by that LCD. This is the LCD of all the fractions. Now multiply numerator and denominator by 1, but not any one. We need a hero one here. Our hero here is this. And this is the solution number 2. So now when you multiply this by this, what you will get? 1. And when you multiply this by this, you will get 0. So it will be 1 plus x squared all to the power 1. And here it will be to the power 0, which will be gone. It will be 1, and you have x squared. Simplify, you will get this. There is a third way. Who can tell me what is it? There is a third way. I advise you, by the way, to use method number 1. Solution number 1, I think, is okay.
Make it 2 fractions.
Yes. What is that called? Distribute. You know, ya Shabab, when you have a plus b over c, what is this? A over c plus b over c. This will be this one over this one minus this over this. And it is easy to be solved also like that. For this one, because we have the same expression. In fact, here, we just have a to the power n plus a to the power m, or minus over a to the power l, for example. So it will be a to the power n over a to the power l minus a to the power m over a to the power n. And you can continue, simplify. Okay? Now, I think you will be able to solve now. This is the same question, but written in a form of all the exam questions. So this is about simplify this, and it will be something like that. Then what is a, what is b, what is a plus b? Now I need an answer from you. Is it a, b, c, d, or e? Practice. Solve. Don't rewrite the question, Shabab. Just start solve. Just write the number of the question and start solve in your notebook. Check your answer. The answer is C. How? The answer is C. Let's see together. So what we will do, ya shabab, we will start with the left-hand side. And I told you as a hint, write this as a rational exponent. This is 1 minus x squared all to the power half. Plus, is it negative half, this one? This is already there. It is x squared multiplied by 1 minus x squared to the power minus a half. Notice that you have the same base, 1 minus x squared, 1 minus x squared, 1 minus x squared also in the denominator. Okay, so this is equals to what? Now what we will do, we will take a common. What is the common factor in the denominator? In the numerator? 1 minus x squared to the power a half or negative half? Negative half. Now we will open a big brackets. Now divide the first term by the common factor. What you will get? 1 minus x squared to the power 1. Plus this over itself is 1 plus x squared. So no need to write this. And we will have, of course, the same denominator. Here we are. This is equals to what? What is inside the shabab? 1 minus x squared plus x squared. What is that?
1.
This is 1. 1 multiplied by any expression, it will be the same expression. Over 1 minus x squared to the power negative 3 over 2. Can you simplify? Yes. It will be 1 minus x squared to the power a half minus 3. It will be plus 3 over. What is negative half? This one. Yes, it's minus a half, of course. Now, this is a type of mistake. When you write, make sure that you are writing it the right way. Now, what do we have?
1 negative x
To the power 1. Now, you need to compare this with what is given for you. What is given is this. He said that this will be equals to this. So this one, you should write it as a x squared plus b. So it is about what? What is the coefficient of x squared? What is the constant coefficient? Now, let me, to make it easier for yourself, you can write this. This is 1 minus x squared. You need to write it as negative x squared plus. The addition is commutative, no problem. So now compare. Now what you need to do, just use your eyes. Just use your eyes. No need to mathematics here. What is the coefficient of x squared? It is negative 1. So a is negative 1, b is 1, and the sum of them is 0. Try to avoid error mistakes when you do this, a plus b, a minus b, a times b, because if it happens, it will be so bad after all of this effort and you lost the grade at the end. Who can tell me what is this equals to? This is the last part of this section.
A squared minus b squared times c.
You are right. What we did, ya shabab, here, we just apply the idea of what? Of x minus y times x plus y equals to what? X squared minus y squared. This is, of course, difference of squares. Similarly, if you have square root of x plus square root of y, if you multiply by square root of x minus square root of y, what you will get? The square of the first one minus the square of the second one. This is a general idea, okay? What we did here, we get rid of the radicals. Look, no more radicals in the result. So this is called rationalizing. We rationalize here. When we want to rationalize or to get rid of the radicals, we multiply by what is called the conjugate radical, or shortly the conjugate. So the conjugate of a plus b square root of c, it is a minus b square root of c. The conjugate of this is this. The conjugate of this is this. Okay? You remember in P4, we know how to, we learned there how to rationalize this. Now, when you have 1 plus, what you will do? You will multiply by what? You will multiply by a hero 1. You multiply by 1. Why? To keep the value. We don't want to change the value. But we don't want here any 1. We need a hero 1. What is our hero?
1 minus
The conjugate over the conjugate. Here we are. The conjugate of this is 1 minus square root of 2, and multiply and divide by it. So now work on what? Work on the denominator. Now, if you multiply this by this, by its conjugate, what you will get?
1 minus 2.
1 minus this 1 squared minus square root of 2 squared, which is 1 minus 2. Now 1 minus 2 is negative 1. Now 1 over negative 1, it is negative 1. Negative over negative is positive, square root of 2, which can be written in this way, square root of 2 minus 1. Okay, another example is this, and this is also from Math 101. In Math 101, you will have the same question, but it will be here limit. They will ask you to find the limit of this when h goes to 0. All of the work will be from Math 001. You will see what we will do to take the limit at the end. So now what you will do, you will try to simplify this by multiplying by the conjugate of what? Of the numerator. What is the conjugate of the numerator now? We will multiply by 1, but not any 1. Is it square root of 4 minus h plus 2?
No, minus 2.
This is not correct.
Minus 2 minus.
It is the one in the middle here. So it will be the same term multiplied by the same term, but here it is plus instead of minus. So this is the conjugate of the numerator. Now, when you have such a problem, be careful, ya shabab, and save your time by what? You multiply by the conjugate of what? Numerator or denominator? So work on the numerator, simplify the numerator, and keep the denominator as it is. This one, just multiply this by h. Look what I will do. Just it will be the square of the first one, the square of this, minus the square of this, over, don't distribute here, don't expand, keep it as it is, h multiplied by that. Now here the square root will gone with square, and this will gone, and you will have 4 plus h minus 4. It is what? H over h times this. Now why we kept h there? It will be now cancelled. How to cancel? This will be 1 and this will be. So what is the, at the end, what we have? Now the limit of this will be the same as the limit of this when the result, what was the result at the end? 1 over square root of 4 plus h plus 2. If you substitute by h from the beginning, ya shabab, you will get 0 over 0. It will be 2 minus 2 over 0. It will be 0 over 0. But here, no, it will be what? 1 over h is 0. It will be square root of 4. It will be 1 over 4. So look at the work. Most of the work is 001. Just this step will be Math 101. Yes.
Aren't we supposed to always rationalize the denominator?
Why not? You can rationalize whatever you want. He said here rationalize the numerator. When you have algebraic expression, you can rationalize both if you want. If you have numbers, yes, we rationalize the denominator. If it is square root of 2 over 2, halas, that's it. If you want to rationalize the numerator, you can do the same. But we are talking about algebraic expressions here, and he asked specific question, rationalize the numerator. Yes, in many situations you need when you have algebraic expression, like this one. Now rationalize here the denominator and simplify. Even if he didn't ask you to simplify by rationalizing the denominator, I think you need to rationalize it to simplify. What is the conjugate? Square root of x plus 1 multiplied by square root of x plus 1. This is what you will do. This is as a hint for you. Done? Let me see. If you are done, let me see what is your answer. Correct. Correct. Excellent. MashaAllah. Of course. Take 2 here as a common factor. Then you can cancel. There will be a common factor. Okay. Continue. Right. Let me show you the result, ya shabab, on the board, and you can, of course, check your answer. check your answer if you want. This will be the answer. So the idea is what? Now, what I told you, Shabab, we multiplied by the conjugate of what? Numerator or denominator? So we will work here. It will be x minus 1. Is that right?
Yes.
Now, in the denominator, don't distribute, don't expand. Just write it as it is. This is very important, Shabab. If you expand, if you multiply, you will lose the simplification, the cancellation. Now this will be equals to what? Now some of you, I have noticed that many of you, they stopped here. You can simplify. Look here, you have 2x minus 2, so 2 is a common factor. Multiply by square root of x plus 1 over x minus 1. Now x minus 1 here is a factor, and here it is a factor. They can be cancelled with each other. Where we are here. Now what you can do, this will be 2 multiplied by square root of x plus 1. And believe it or not, I have seen some students, they did this mistake. And if it is in the choices, this will be the worst end for your choice. After this, all of this effort, and you did this mistake, be careful about it. It is about the distribution property, the distributive property. Clear? Okay, let's now go to the most important part. And in fact, it is the most difficult part for me. I don't know what can I do for you, Shabab, to avoid such mistakes. Let's read this. Do not make the mistake of applying properties of multiplication to the operation of addition. This is the main mistake, in fact. All the mistakes are coming from mixing up between what is applied for multiplication is not necessarily applied for addition. And here we are some examples. These are correct when we talk about multiplication, but they are not correct when we have addition. Look, you can distribute the power over the product, but not over the sum. The radical, when you have square root or any radical, you can distribute it over the product, but not over the sum. Similarly here, it is about distributing. So most of you, when we have something like this only, you can cancel now. It is about if they are positive, of course. But of course, in the case of addition, you cannot distribute. Here, of course, about the reciprocals. When you can cancel here, when they are factors, but not when they are terms. This is not correct. This is what you did today. When you can distribute the power over them, but not in the case of the sum. You can, ya Shabab, add more and more. So, in fact, for each one of you, he has his special errors, his special common mistakes. So try to minimize the number of your mistakes and errors. Try to write them down. Today I did this mistake. Write it down and highlight it. See what is wrong. And always when you have an idea about strange formula, take numbers and check if it is the right one or not. Take numbers and check your formula. Yeah, Shabab, usually I tell my students the following. Use the well-known formulas. Don't use your own formulas. Okay? Many examples can be, Shabab, considered when you want to check any formula. When you have strange idea, check by numbers, taking numbers. For example, if you are thinking about, for example, let's say 16, you are thinking about a plus b to the power -1, so you will say it is a to the power -1 plus b to the power -1. Or even if you have it in the another way. Think, for example, about, let's say 16 and 9. This is a good example about square roots also. Is it the same if you did it this way, 16 to the power plus 9 to the power, do it like that, and so on. So think about numbers. You can think about numbers and choose, of course, different numbers if you are not sure. Or you can, ya Shabab, work on simplifying one side in a different way and the other side in a different way. If they get the same answer, so it is correct. Otherwise, it is not. This is the summary of this section. And you have, ya Shabab, here so many solved exercises. Don't read the solution. practice, and then check the solution. So many old solved exercises and additional exercises with final answers and exercises from your book. We solved all the recitation exercises for P7 because they were important. And I solved also here for you many old exams to just give you an idea about how to solve such problems. Yes. Now I will go back after that. Look here, when you have absolute value, one of your colleagues in the previous class asked me about how to rationalize the denominator when you have absolute value. What will be, who has an answer for this? Yes.
We first will check if it's gonna be a positive or.
We need first to deal with the absolute value. We need to remove the absolute value, to write it without absolute value. So we will ask ourselves, what is inside? Is it positive or negative?
Negative.
It is negative. It is less than 0. So what we will do? We will remove the absolute value and multiply by -1. So look what it will be.
Gonna be.
Now rationalize. Now it is P7. This question is a combination of P2 and P7. I wanted to solve this. We still have time. Unfortunately, we don't have time. But you can have a practice by solving this. I solve it. I did solve it with the previous section. You can practice by solving this. What you will do? The LCD is this, and the LCD is this. You multiply this by this by this, and you will do the same there. And you can practice by solving all the old exam questions. See you, Shabab, on Thursday. We will, inshallah, study P8 on Thursday.
Thank you so much, Dr. Rahman.